Assalamu alaikum and hi for everyone. My name is Fathullah Muhammad Fathullah Al-Gamoudi. So today we will present our group project, which POLYPHASE network system assessment substation. We are from section 4 and group 2. And for our group member, Jeffinides and Arif and Chan Chong and Fathullah Muhammad and Fritz bin Tal. And our lecturer, Dr. Mahyuz bin Jannah. Our group member, Jeffinides, he will present the video slides and he will do a compilation for our video. And Arif and Chang, they will present discussion part. And Fatullah Muhammad, he will find the information required. And for Fidris bin Talib will present introduction and conclusion part. So that's all, and thank you so much.
Assalamualaikum. My name is Fidris bin Talib and my MFA number is BE20403. I'm from section 4 group 2 and today I'm going to present about our topic, which is single line diagram. For my part, I'm going to present about introduction and a little bit explanation about substation. Single line diagram is the representation of power system using the simple symbol for each component. In this report, the objective that we need to achieve is study and explain the given single line diagram of power system. And power substation is subsidiary station of electricity generation, transmission and distribution. The substation that has step-up transformers increase the voltage with decreasing current, while step-down transformers decrease the voltage with increasing current for domestic and industrial distribution. Thus, a single line diagram will clearly show configuration of components and how are them be connected to each other in electrical system. That's all for me. Thank you.
Hello, my name is Arif Basic number AE2001 for the discussion for the Siemens substation single line diagram. Above, we can see the whole power system line diagram from the top to the end. In the single line diagram above, the component that used in is stated as above, such as 3-port converter, TVC 69 kV, bus bar, transformer, rectifier, inverter, are the components that also used in this single line diagram. Gas turbine, generator, solar PV, wind turbine generator, and energy storage. The future information for SFT above will in the next slide.
Thank you, Arif. Now I'll continue to present the remaining presentation. Before that, let me introduce myself. My name is Chin Chong Wei. This is the Siemens plant power system single line diagram which selected after our group discussion. From the top, we can see that 3-port converter TVC which supplies 69 kilowatts is connecting to a transformer T1 which is a step-down transformer and a bus bar bus 1. The voltage is stepped down to 11.4 kilowatts and another transformer T2 is used to step up again the voltage to 380 watts. Bus 2 is connected to the second transformer T2 before it feeds the supply system SS for the remaining distribution of power supply. A bus bar is used to connect high voltage equipment at electrical switchyard and low voltage equipment in factory banks. From the supply system, we can discover that bus 3 and bus 4 are connecting with wire lines to feed the voltage to the 230 kilowatts loads. On the other hand, look at the bus 5, a rectifier and an inverter are connected to the gas turbine generator U. At bus 6, we also can see that another 2 rectifiers are connected to solar PVS and energy storage B. The purpose of rectifier and inverter are used because they have the highest possible transformer utilization factor for a 3-phase system. Next. From bus 8, we can see that the supply system contributes 380 watts to 230 kilowatts loads, whereas at bus 9, another wire line is connected to 130 kilowatts loads, which also receive 380 watts from the supply system. A transformer is connected to the bus 10 and supplying 380 watts to 3 components, such as solar PV and 2 wind turbine generators respectively. A rectifier is connected to the solar PV, while a rectifier and an inverter are connected to the wind turbine generator respectively. On the other hand, another transformer is connected to the bus 11 and supplying 380 watts to the solar PV and gas turbine generator respectively. A rectifier is connected to the solar PV, whereas a rectifier and an inverter are connected to gas turbine generator respectively. That's all for my presentation today. I will pass to Jaswenders to continue the remaining presentation. Thank you.
Thank you, Chung Wai. Hi and hello. My name is Jashindas. My matrix number is AE2028. Today I'm going to present to you the conclusion of our project. Single line diagram is an effective way to represent a complicated and complete conventional diagram which showing all the connections in a more convenient ways. In a single line, standardized schematic symbols are used to represent all components of a power system. In this case, several symbols can be used to represent the components in the single line diagram. As modern substations are being designed, electrical layout is receiving considerable attention with regard to reliability. A reliable substation design has ultimate impact on system performance. The immediate consequence of poor substation design is the failure to contain common single outages. The results of multiple outages which stress the system unduly since the grid is operated only on a first contingency or single outage basis. Substation automation, control, and communication provide the information that is required in real time. Typically, the intelligent electronic devices, IEDs, that protect, sense, and generate data on substation equipment operate independently. Throughout this assignment, it is a crucial fundamental knowledge for us to read and recognize line diagram, which will help us analyzing the more complicated single line diagram. That's all from us. Thank you very much.